Welcome to the Beyond 3D podcast, where we explore all things 3D and the important role that 3D data plays throughout the manufacturing process, driving decisions throughout a product's lifecycle. Here, we talk with industry analysts, business owners, developers, and industry influencers, and hear real stories that you can relate to and learn from, and know which trends and technologies apply to your business. So join us as we go Beyond 3D. Welcome, everybody, to another episode of Beyond 3D. Hope everybody's doing well out there, enjoying the summer that's approaching. And we are super excited to have a good friend of ours on the show today, Jennifer Herron, who is CEO of Action Engineering. And she's also a certified SolidWorks associate, author, and the list goes on and on and on. And we'll include a little bit more about your bio in the show notes. But welcome, Jennifer. We're so happy to have you.
Thanks.
And we have from TechSoft 3D, Dave Opsahl, Vice President of Corporate Development. Hi, Dave.
How you doing, Angela? Hi, Jennifer.
Hi, Dave.
Doing well. And we have Tyler Barnes, Vice President of Marketing for TechSoft 3D. So today we're going to be talking about MBD. So for those of you who know what the acronym means, this will be all very familiar. For those of you who don't, we will give you a little bit of education on that. And so before we jump into MBD as a topic, Jennifer, could you tell us a little bit about yourself and Action Engineering?
Sure can. So my name is Jennifer Herron, and Action Engineering is the company that I founded several years ago when model-based definition and model-based enterprise, which are the MBD and MBE acronyms, started to take hold and have been developing and evolving with that ever since. So we help organizations, both large and small, achieve their model-based definition and enterprise goals. And often those really, you have one and not the other. They go hand in hand. And we try to do that by motivating stakeholders. We deliver training when we provide business planning and implementation consulting services.
Thanks for that background. So when it comes to MBD and model-based definition, do people know what that acronym means? Is it pretty well known, or is there still some education to be done? I mean, for me, I constantly have to remind myself that the D stands for definition and not design, just because it's so ingrained in the design world. So what's the consensus out there? Is there still some education to be done?
Well, interestingly enough, I'm actually physically in Tampa, Florida right now with the American Society for Mechanical Engineers, ASME. And tomorrow we will discuss a standard that has been developed over the last 2 years. And we actually have a definition that we will be publishing for model-based definition. And that's the D there. But to answer your question, do people really know what MBD is? They definitely have the basic concept, which is they know that they want to use their CAD models and they want to reuse them either for manufacturing and for quality through the procurement process, but they don't really know what that means. And they don't know, am I doing model-based design? Meaning, do I try to incorporate the FEM, the finite element models alongside the CAD models? Are they one and the same? How do we incorporate all that? Or are we really just talking about product definition and an improved process over a 2D drafting? And I've actually just in the last month heard the D be called model-based drafting. I would probably be opposed to that term in general, but that's one that's been thrown out for the D as well. So model-based definition is typically what I mean when I say MBD, and that's talking about the product definition, the dimensions, the tolerances, the notes, the appropriate metadata or administrative information that has to go along with your products that you build.
So it sounds like people have all of these questions that relate to it, but don't know that, what you're describing is now considered model-based definition.
Right.
And so Dave and Tyler, are you kind of seeing, what are you seeing when you're talking to customers? Are they saying, here's my problem, here's what I want to do?
Well, I think for us, the interesting thing is Jennifer is primarily dealing with the end users who are actually trying to achieve that. From our business perspective, we're usually talking to application developers that are trying to figure out how to deliver solutions that make that possible. But not surprisingly, a lot of the same confusion exists there. And, they also need some of the same kind of help from a different perspective, which is how do we actually build applications that can accomplish this in a better way? I think, Jennifer, you'd love to hear what you think about the adoption difficulties that people have in trying to use the tools to achieve some of these things, and whether or not there's room for improvement there. I suspect you would say there probably is.
I think a best-in-class organization, whether you're a software developer or you're producing products, always is continuously improving. And I would suggest that everybody look at model-based definition as a continuous improvement program over what they have in place today, so that they can bang out some efficiencies in their processes and recover some costs. Unfortunately, to do that, it's not just about throwing together a software package at it or throwing some software at it. It's an overarching process that has to be attacked at the enterprise level to find all the inefficiencies so you can actually get return on investment out of it. But yes, to answer your question, different software packages have interpreted the standards. For instance, I'm sort of ASME centric this week. ASME Y14.5 is the geometric dimensioning and tolerancing standard that governs how everybody, or should govern how everybody is tolerancing their drawings today. And the problem with that is that, just like everything, it's left a bit to interpretation. And as we move towards model-based, there is less structure associated with how to do that in a 3D annotated space. And so there's a lot of interpretation that's gone on at individual, either CAD software vendors or folks like yourself, where, you've got to make choices because you're building software, and the choices just get made a certain method, not that it's right or wrong. They just get made a certain way. And in some aspect, people are sort of playing around with, what do we do with all this 3D stuff? We have all this opportunity, and, look, I can spin it. That's great. But one of the things you guys just put together with Enrich that I really like is when you click on the parts list that's in a nice tabulated format, the part flashes green and highlights in the dynamic space in the middle. And I think that's great. And that's something, I didn't think about. And you just, those are the things that, we have lots of opportunity to make those improvements. But they may or may not be consistent because everybody's got their own creativity and ideas and innovation they can throw at it. I have a bit of a long-winded answer.
Oh, that was great. I have a bit of a follow-up question. One thing you were talking about there was MBD being something you're continuously improving upon and looking at it from the enterprise level. And I think that's one thing that is a misconception, is that it's only happening at the aerospace companies of the world. And you're doing a ton of this, Jennifer. Like, can you give us some examples of different types of companies doing it? Is it just the big companies, or are you seeing it kind of playing out into mainstream manufacturing as well?
So big companies are looking at it in a more, I would say, holistic manner within their configuration management practices. How do they take these very well-established drawings that are most likely based on all the ASME Y14 product definition? How do we take that, evolve that into model-based? That's kind of it's a big elephant in the room, is what we always talk about. Big elephant to eat, right? Small companies, however, are actually more interesting to me because they don't really care that much about process and procedure. They just have to get their stuff out the door. So therefore, they're making choices every day on the fly. And if it's easier to represent something in a model than it would be otherwise, they don't think about it too much. They just do it. And I know I work with a small company that they have in-house manufacturing that's right next door to, literally a wall away from, actually two that I've worked with, a wall away from the floor building the stuff they're producing. That's actually the ideal situation because, I can make a quick model change here. Oh, that hole's the wrong size. I need an extra, I need to, make that fillet radius smaller so I can fit the right bolt head in. Here, let me change it. Boom, it's out on the floor now. And that's the ideal quick repetitive cycle that we're really trying to drive with model-based definition. And a model-based enterprise is somewhat simpler because the elephant is sort of smaller in small business. That's my take.
Along those same lines, the research that we've all been sort of involved with that has come out of Life Cycle Insights that sort of dispels this notion that what you really should aim for is complete elimination of drawings. Does that kind of go a little bit to this, continuous improvement thing where you've got a maturity curve that people want to move along a progression? They don't want to go from completely 2D to 2D documentation all the way to drawingless documentation. There's actually a point in time where it's probably you're not going to get the return on investment if you go completely drawingless. Can you comment on that?
Yeah, I think that's good. And Angela, I know this is one of your questions, which are what are the common misconceptions of MBD? Mm-hmm. And I think this is one of them, is that MBD is about getting rid of drawings. I'm not particularly fond of that methodology. First of all, it means that everybody who is a drawing drafter or drawing checker gets very nervous they're going to lose their jobs. Not a good plan as far as trying to get those people to accept this as a improved process. The other is that, well, the obvious person is going to come up and say, yeah, but I make washers, and washers are 2 circles and a rectangle in a drawing, and I don't think I need to go through all the trouble and effort of making those represented in models. Well, that may absolutely be the case. But if you were an extremely complicated manifold with 15 inputs and 5 outputs that are all at different angles, and it has to fit in this crazy widgeted shape because it's compressed, like inside an airplane wing or something, now we're talking about where MBD can really make a big impact. So from that perspective, the focus, rather than being on get rid of drawings, should be we can really use model-based definition on this extremely complicated geometry and convey this product definition and its design, manufacturing, and quality inspection intent in a much more streamlined manner with a much better visual communication tools. So that, to me, is a better way to focus, because, yeah, you may never get rid of the 2D drawings of flat washers, and that may not, because that's not a good business practice. But if you can drive out hundreds of thousands of dollars of cost in a complicated, complex shaped part, that's where you're going to see a major return on investment.
So that's like incredibly thorough, and I'm trying to figure out what's the next best question after that, because that was actually a really great explanation of really how to approach, defeat that misconception and really embrace MBD, if you will. So actually, what are some of the most common questions that you get when a company wants to start implementing something? They may not come to you with MBD, right? Like, I want MBD. They come to you with like, listen, we have this issue. How do I approach it? So what are some of the most common, I guess, issues or questions that you get?
I think the most common question I get is, oh, it looks like you have some training. Can you just tell me then how to do it? Just tell me what I need to do exactly at my company. Well, okay. We do have training, and yes, I can tell you about what model-based definition is, but they think it's more settled and packaged, even by the standards organizations, for instance, or the industry as a whole has this very prescribed way that they're doing it. And I think that's probably what I get the most of is train me how to do it the best way. And the best way is very specific and unique to the organization. Mm-hmm. Although there are common pitfalls across all organizations, and that is what we train in, the common pitfalls, and let me explain to you about this software versus that software, that kind of thing. But because it's evolutionary, there are choices that are made across the entire enterprise that are going to affect how model-based definition is implemented. And lots of times people say, well, all I need to know is how to put annotations or PMI into the model. I don't need a PLM system, and I don't need a data management system, and I don't need all that stuff. But the problem is that it's all interlinked.
Right.
So you can't just talk about one without the other.
And so MBD as a process continues to evolve, right? I mean, is that an accurate thing to say? So that you can't just have,
Absolutely.
okay, well, I had training on MBD, 3 years ago, so I'm good. So with that thought in mind, where do you see MBD going and evolving, the next year, 2 years, 5 years? Like, how do you see things progressing?
Okay, that's the next question. I don't know how to answer.
That's a big question. As I was asking, I'm like, wow, this could be a really loaded question.
Yeah, but, exactly.
And it's hard to, maybe it's just some speculation, but
it's very contingent on the choices that you make. So, for instance, how long does it take? I get that one a lot. Well, it depends on how committed you are or what kind of resources you have allocated. If you don't have money to buy the latest software that supports PMI, I can't help you. So my prediction, and I'm a glass half full kind of person, so you have to take that with a grain of salt. I'm not all that skeptical, actually. I think that we are in an explosion time period where we've got additive manufacturing flooding the manufacturing scene and exciting everybody from 4 years old to 80 years old. And that is helping to bring people to the table that might not have come to the table in the past. And it's opening their minds a little bit more and saying, oh, well, I've got to have a model. Maybe I should figure out how to use that CAD software stuff. I actually had a flight attendant. I was doing some presentation, and, I had a model on the screen. Flight attendant come by and say, hey, is that CAD modeling stuff? Is that the 3D printing? I said, yeah, it is. And he said, well, I'm gonna have to learn about that. And I said, well, yeah, here's the program you should go learn with. And so, so I just gave him some tips, and he was all excited. And, so I think that kind of excitement over all human beings, never mind just the engineers, is growing, which kind of increases the whole buzz around it in a significant way. So, but I'm a glass half full kind of person.
That's in line with what we see as well, Jennifer. We work with, all sorts of different engineering software companies, and there's no doubt that whether you call it Industry 4.0 or model-based definition or digital twin or digital thread or digital continuity, there's a trend towards kind of linking these things together and making better use of the information in the model in all sorts of different parts of product development, whether that is for manufacturing, whether that's for inspection, et cetera, et cetera. And we're seeing that happen with all different sizes of companies just through the lens of the software companies that we're working with. It's a trend that we're seeing over and over again.
It's increased, I would say, pretty significantly last year. I feel like we all sort of got on the train last year, and the train has taken off.
I agree. I mean, that's one of those, it's been kind of reserved to the domain of the very high-end CAD systems until recently, and now you've got Inventor and SolidWorks and kind of just more of the mainstream manufacturing companies really talking about it. And, that gets driven a lot by their customers. So that's their customers saying, hey, this stuff is interesting. It's not just for the aerospace companies or the automotives. We can benefit from it too.
Yeah.
The other trend from a 3D printing perspective is that every K-8 school now has got, and all high schools and colleges all have a 3D printing lab now, almost all of them. And that's a big deal.
Yeah, it's becoming part of the common lexicon, if you will, right? I mean, it's becoming the cool thing. And if you're not doing it, where are you? Where have you been? What rock have you been under, right? Even if you don't know how to do it, you're talking about it. So for sure. So something that you mentioned in your answer to the, where is MBD going in the next 5 years or whatever, was about resources. And, if you don't have resources to put into this, you're not going to get very far. So what should companies expect in terms of, time frame and budget and training, and when they'll see their first results? And so I know it's all going to depend again on which project and how big your company is and things like that. But maybe we could take it from a scenario standpoint. Like, we're going to get started with this small process over here. And, what does that look like versus, a much larger implementation?
Yeah, and I'm going to give you a lot of caveats and disclaimers surrounding all of this. But yes, well, the first thing I've noticed, is the time it takes kind of an individual person to make the shift to understand the difference between a drawing-centric and a model-centric process for design processes and the whole product life cycle. And people get started on it and they think, they've got a preconceived notion, oh, it's model-based design, I get to use it, for everything. And then they start researching and attending conferences and talking to software vendors. And they kind of go through this period of elation and excitement, and then they kind of get the reality and they sort of drop off. It's sort of like the technology curve. They get high, then they get low, and then they kind of level out. That whole time period, and I don't know if this is a human thing, don't ask me, that's not my expertise, but it roughly takes people about 2 years to get to research, absorb the information, and then get to the point where they can actually be productive and make something happen with it.
Interesting.
What do you guys see? Yeah, Dave and Tyler. Maybe you see something similar.
No, I think Jennifer's experience is pretty similar to what we see. A lot of it is just the validation that it takes, for people to believe that the investment that they're going to make actually, can produce the return that they're looking for. That's going to get easier. But I think Jennifer's point earlier is still valid that, this is really, it's a lot like the way people talk about product lifecycle management. It's not a product, it's not a piece of software, it's not a solution. It's a business philosophy, a business approach, or a process. And you're constantly working on various elements of it. And, the best way to screw that up is to start off with a bad plan. And so, it does take time to figure out how to put that together. And that's the same thing that we see and that the application developers we work with see.
So 2 years is a long period of time. And then a lot of doubt will be raised during that time period, whether this is the right thing to do or not. So that's the advantage of, and I'm not plugging myself, but it's the advantage of working with a company like Action Engineering, because we can kind of cut out all that learning curve up front, and say, these are the things that will ensure success. And if you just follow this plan, that's unique to the corporation. But if you follow that plan, then we can get there faster, and hopefully the folks will come up faster. One of the other things is training, of course, and we and I am constantly trying to figure out, based on the feedback from other training that I have done, how can I get you to this? How can I get you to my level of understanding faster? And sometimes I'm successful and sometimes I'm not, but it's incorporating as many, obviously, learning styles and multimedia and stuff like that as possible to get folks there faster. And so those are kind of the other things. And as far as budget goes, the things to consider for budget are obviously software costs, but the next big cost is the labor involved in sort of retooling and retraining your folks in a new process. And you can minimize those costs by the executive leadership driving from the top down the imperative for change. And that, we have defined a new process, which is the first step. Define your new process. And then remove all the barriers that people are going to come up with for making excuses about why they can't do it. So whatever it is it, buying them a tablet for the shop floor so that they don't have paper on the shop floor? Is it throwing all your printers in the trash? There's a variety of options, that can be taken, but you have to remove all the barriers that would prevent them from being successful with the procedures that you have defined. And then you've got to make them accountable to those procedures. So, one of the problem with having, for instance, a modeling standard, you can have a modeling standard and it can be absolutely perfect, but if nobody's following it and doing it, it's totally useless. So that accountability of the folks changing to the new methodology is important. And those things reduce the time and money that you're spending on the implementation.
The one thing, Angela, I'd add into there that is, coming at this from a little different perspective is I think Jennifer's right about the value of companies like Action Engineering and being able to short circuit some of that time. Something else that we're seeing, Jennifer was alluding to at the end of this, which is, the people that come up with a lot of reasons why they can't adopt to this new process or follow that new process. And one of the things that we see providing, components to people that develop tools is that the standards of what constitutes an adoptable user experience is changing. In other words, people expect things to be a lot easier, and are incorporating some of these standards, how those get applied to the way software is performing its function. You've got a lot of people that we work with, and I can think of a half a dozen manufacturing startups that we're working with right now, where the average age of people in those companies is probably less than 40. Mm-hmm. And, they've grown up with, mobile devices and very simplified, effective user experiences and things like that. And that's going to have, I think, a benefit too of making some of this technology that supports these things easier to adopt. And that will go to a shorter time frame, it'll go to better ROI, and it will do everything out there to open up the market for, more of the training and more of the focus around the process that Jennifer's talking about.
Yeah, I'm giving you a thumbs up, and I've recently read a book. I've recently read a book that talks about those, that younger generation is they're basically digital natives. The interesting thing about me is I am definitely older than those younger folks, but my father was a computer scientist, so I had a computer in my house forever, since I have grown up, and that included the 70s. So I have a level of expectation that the computer will do for me what I want it to do. And I was taught coding, when I was like 10 or something like that, how to do go-to line programming kind of thing. So, and my son is 12, and he is able to navigate a 3D world with there's no barriers to success there for him, from his mind, because he's a digital native. Now, there's some downfalls to all that stuff as well, like too much screen time, blah, blah, blah. But if we look at the positive benefits of, workers that have grown up with that access and expecting that the computer is going to do all that, they really won't think anything of eliminating a 2D paper drawing. Just having it in 3D is a no-brainer.
And you mentioned, and I totally agree with what you were saying. I mean, we see it even with kids that are super young, right? That are able to navigate mobile devices like a pro, at 4 years old. And so you just think, gosh, what are they going to be able to do when they become teenagers or into the workforce? So that kind of leads to my question. You had already mentioned that in almost every school, there's a 3D printing laboratory, but from the MBD or even PLM and some of these types of concepts and processes, do you see that kind of content making its way into schools so that students, when they graduate, come into the industry already having this kind of understanding, and you don't have to go through that 2-year process of educating and, dispelling,
Yeah. Well, I would say the place that I've seen that most successful right now is at Purdue, where they have MBD certificate programs.
Really?
And so they have a PLM certificate program, and then they evolved that into a concept of MBD certificate programs for specific CAD systems. And so they have that as an offering for college students. So, but they're fairly unusual because it's the Purdue Technology College, and I apologize to Dr. Hartman for probably just bastardizing that name, but institution is very specifically focused on model-based processes through CAD, through lifecycle management. I think that it's only a matter of time before other colleges sort of pick up that trend. For lower grades at some level, it's probably just enough to get them to model in 3D. And in fact, just this from January, I've been helping out our technology teacher for our middle school kids at my son's school. And they just pick up the 3D modeling just instantly. And then there are kids that look at a picture, of like an X-Wing fighter or something, and then they just build the X-Wing fighter. Look what I did, and it's nothing, So I think that sort of 3D spatial training that's being done now, so to speak, is definitely happening at a younger age. The product definition portion of it is much more, okay, I have this widget, now I want to get it built. And that's more of like a design for manufacturing and quality and those kind of programs that all still apply to 3D, even though they're probably taught right now on 2D. So I'm not sure that answered your question, but yeah.
No, it does. I mean, it was interesting to hear that Purdue, it has that kind of program. Is that really one of the only universities that has a program like that? I would have guessed that at this point there would be a few colleges that have some sort of program addressing.
I would say there's a lot for like manufacturing and quality,
right?
But not specifically in 3D modeling. And I think Purdue is been on the forefront of trailblazing that. Manufacturing processes for with 3D models.
Right. Well, I think that could be a whole other podcast conversation as to why it's taking so long for that content to make it into the university level, especially in the manufacturing program. So we won't go down that hole.
Yeah, I was going to say, I'm going to definitely refer you to Dr. Hartman for that one, because he's been doing that for definitely the last 15 years. So that's his bailiwick for sure.
Wow. Well, this has been really, really great. I hope that the listeners have found the information helpful and they have a now much better understanding of MBD and maybe are a little more open to it and embracing it if they haven't already. We are at the end of our time. And one thing that we do ask all of our listeners at the end is to, not our listeners, I'm sorry, our guests, is to pose let's say a request or a challenge to our listeners, an action item that you'd like them to do after having listened to this podcast. It could be, like I said, it could be a bit of advice or it could be a call to action. But what would be one thing that you'd like to say to our listeners today?
Okay, wasn't prepped for that one.
Sorry.
That's okay. One thing I didn't, probably this is what I'll do, is the basic definition that we're putting forward in ASME for model-based definition is to use an annotated model without having to use a drawing. So perhaps my challenge would be, can you take one of your drawings that you have, and if you do have software that can produce MBD and 3D annotations, explore taking all that information from the drawing and putting it into the model, but don't do it from the straight fact where you're just copying all the 2D drawing information and putting it into the model. I want you to think about each and every annotation and if it's important in a model-based world, because you already have 3D representation that is most likely going to be interpreted by a machine and not a human. So if you look at every single dimension on a drawing that you have, if you didn't have to interpret that by a human, what might it look like?
Okay. And any recommendations on tools that they might use to do that? If they say, okay, I have a drawing, but not sure how to do what you just described.
Yeah. What would be the tools to do that? So I'm going down in price order. CATIA, NX, Creo, SolidWorks, and Inventor, Inventor 2018, I think, all have 3D annotation tools. They're often called PMI tools or MBD tools. And you can apply annotations in each of those tool sets And then many of those tools also will publish to a 3D PDF and play around with the PDF publishing, because you will find it's not all equivalent. And the important thing to understand is that we really want to keep all the digital associativity between the dimensions and tolerances that are displayed with the geometric features that they represent in the model. And so the cross-highlighting and visual response that's in the native model but then gets translated to a derivative like a 3D PDF is critical. So, and that quality varies with each PDF publishing method.
Right. And we certainly have a 3D PDF publishing tool that we will let our listeners know about with Enrich as well. So we'll be sure to put links to all the relevant information in our show notes. And with that, thank you so much, Jennifer, for being with us today. I think it was an excellent show, and we're going to have you back very soon. So thank you for taking the time to be with us today.
Yep, my pleasure. Thanks.
Thank you, Dave and Tyler, as always, for being with us and providing your thoughts.
Always a pleasure.
Happy to be here.
Awesome. Thanks, everybody. And for those of you listening, thank you for joining us. If you haven't subscribed to Beyond 3D already, please hit that subscribe button and share with your colleagues and any friends or family who you think might find this show interesting. And we would love for you to leave us a review on iTunes. It would help others find us and listen to us as well. And with that, we hope you're having a great day. And until next time, we look forward to having you on our next episode of Beyond 3D. Thanks so much. Bye-bye. Thank you for joining us on the Beyond 3D podcast, hosted by TechSoft 3D. Be sure to subscribe on iTunes and leave us a review, or subscribe on SoundCloud. To listen to past episodes or learn more about TechSoft 3D, visit www.techsoft3d.com/blog. Send us comments and suggestions at info@techsoft3d.com. Thanks again for listening, and we hope you'll join us again on the next episode of Beyond 3D.